Welcome back to part 2 of section 4.2, the complex numbers. So this is the backside of our complex numbers paper. So simplifying the radical. As we discussed, we want to rewrite negative 400 as products with at least one perfect square. So we will have I'm going to rewrite that negative 400 as square root of 400 times the square root of negative 1. And if you remember, we are still focusing on right over here, I squared equals negative 1, I equals square root of negative 1. So every time we take the square root of negative 1, we know we will have an I. So square root of 400, that is a perfect square. So we have a positive negative 200. Square root of negative 1 is I. All right. Simplify the radical. Again, I'm going to rewrite that as square root of 289, which is a perfect square, times the square root of negative 1. Square root of 289 is a positive negative 17. Square root of negative 1 is an I. So that's how we simplify the radicals. Pretty straightforward. Rewrite as a perfect square, square root of negative 1, which gives us the imaginary number I. All right, let's look at 11. Solve the equation. Solutions can be real or imaginary. Very good. So, first thing we want to do, we don't necessarily have anything to factor, so we have enough room. We're going to isolate x squared. So subtract 81 from both sides. That leaves us with x squared equals negative 81. Take the square root. Square root of x squared equals square root of negative 81. Square root of x squared is simply x. I'm going to rewrite square root of 81 times square root of negative 1. What does that leave me with? X equals a positive negative 9, square root of 81. Square root of negative 1 is I. All right, so isolate the x squared, and just like we did above on numbers 9 and 10, we break that down into perfect squares and solve. Solve the equation and graph the parabola. Number 12. This actually is just like number 11, just different numbers. And we're going to answer a couple of questions. Okay, so we want to isolate x squared. That's going to give, remember, subtract 4 from both sides. So x squared equals negative 4, which I can take the square root of x squared, square root of a negative 4, which square root of x squared is just x. I can write that as square root of 4, square root of negative 1. That leaves me with x equaling square root of 4 is a positive negative 2. Square root of negative 1 is I. All right, very good. So now we need to graph this because they gave us this graph. X squared plus 4. We know that our y-intercept, in this case, h is 0, k is 4, 1, 2, 3, 4. And to do my graphing, go over 1, up 1, over 1, up 3. I can't go over 1, up 5 because I ran out of space. So go back to the left, over 1, up 1, over 1, up 3. And I should have a graph that looks kind of something like that. Kind of something like that. So if you notice, I do not cross the x-axis, so I do not have any real roots. Okay, are the solutions real or imaginary? We see the I up here. So we know they are imaginary. Explain how you know the solutions are real or imaginary. Okay? Because we don't cross the x-axis, we know they're not real. But we can also, what is another way? If we find the discriminant, b squared minus 4ac. All right, so when I look over here, I'm just going to write a, in this particular case, is 1. B, I don't have any x's, so that's 0. C is 4. So when I do b squared minus 4ac, I have 0 squared minus 4 times 1 times c is 4. So I get a negative 16, which, because that's negative, I know I have 2 imaginary roots. So we'll put b squared minus 4ac is negative 2 imaginary roots. Okay? I think I'm supposed to write that in red. You didn't see that. All right, let's try again. B squared minus 4ac is greater than 0. No, it's not. It's less than 0. Who wrote that? Is less than 0. So we have imaginary roots. And of course, we find those roots to be plus or minus 2i, which we did earlier. All right, let's see. Last problem. How do you see it? All right, graphs of these 3 functions are shown. Which functions have real zeros? Real zeros, we will cross the x-axis. Imaginary numbers, we will not. Okay, so let's see. Here, we do not cross the x-axis. Here, we touch the axis 1 time. Here, we cross the x-axis twice. So let's see. Let's write a little something here. So here, I'm going to have 2 imaginaries. Here, I'm going to have 1 real. Here, I'm going to have 2 real. All right, so what did they ask us? Functions are labeled f, g, and h. Real zeros are going to be f, oops, do that in red, f, and g. The only imaginary, because I don't cross the x-axis, is h. With that, we're done with page 2. So do not forget to turn this in. Hopefully this has helped. I will see you on the next page.